Let's begin with this chapter called Auxiliary Views. Let's look into the objectives that we are going to cover in this chapter. The objectives are, first one is what are auxiliary views? Why are they used? Purpose of drawing auxiliary views, true length of a line, and foreshortening. What is that? What does that mean? Then we'll see how to create auxiliary views from orthographic views using the folding line method. We are going to see different types of auxiliary views, which are depth auxiliary view, width auxiliary view, and height auxiliary views. We are going to learn how to draw auxiliary views using the center plane reference method. We are even going to learn how to draw partial auxiliary views and half auxiliary views. Then we are going to look into what is dihedral angles, how to find a true length of an edge, a true size of an oblique surface, and obviously we have auxiliary view exercises that we are going to cover throughout this lecture. So let's first begin with what is an auxiliary view. Now it's important to understand that an auxiliary view is an orthographic view, just like the orthographic views that we have made before, like even sectional views are orthographic views. But these are not one of the 6 principal orthographic views. The 6 principal orthographic views would be your top view, your side view, your front view, the other side view, the bottom view, and the back view. But when it comes to sectional views and auxiliary views, even though they are orthographic views, they are not one of the primary orthographic views. Now, orthographic views are used to determine the true size and shape of features that would appear foreshortened in any of the principal views, which being the top, front, side, left, back, bottom. So first thing we need to understand the term foreshortening. Now if you look at this view over here, this is just a simple view. This is the top view, the front view, and the side view. Now if you look at this surface, if I number it, this is 1, or let me number it as A, B, C, and D. So what happens over here in this object, which in 3D looks something like this. Let me just make a really quick sketch. So in 3D, the object looks something like this. So what we are seeing from here is this view. This is the front view. This is the top view, so we see this surface and this surface. And this is the side view, where all we see is this surface. Now what's happening over here in these 3 principal views is when I project my edges, if we look at this example right here, we have A, B, C, D, which is a surface, and this surface is inclined, as you see over here. It's at an angle. And the same thing over here when I project, even though I get A, B, C, and D, what I have over here is an inclined surface. So if I try to measure this height, and if I try to measure this distance, is it going to be the same measurement as this surface in the front view? That's the question mark. Is it going to be the same distance or the same size, or does it look foreshortened? Meaning, does it look smaller than the actual surface? So that is what is happening over here, is something called as foreshortening, where none of the principal views is showing the correct size. So that is the reason why we make auxiliary views. So instead of looking like this from the top or the side, what I'm going to be looking at this object is at an angle which is perpendicular to the surface. So I'm looking at the object from this angle. So this will be my line of sight. When I'm drawing the top view, my line of sight is this. When I'm drawing my side view, my line of sight is this. But neither the top or the side or the front is showing the exact size. It's showing a size that is smaller than the original surface. So that is the reason why we have to draw auxiliary views, and the way we do that is by moving our line of sight perpendicular to the angle surface. So now we have a good understanding of what foreshortening is. So let's go and see an example of how to make an auxiliary view using the glass box method, using the folding line technique. So now what we do over here, we put the object in a glass box and then project the edges to the surface of the glass box. Now this is what gives us our principal views. But what we are doing over here, which is a little different, is instead of having just the principal views, we cut the glass box, if you look over here, at an angle which is parallel to your inclined surface, and then project that inclined surface onto the cut surface of the glass box. It's just like we did orthographic views with the glass box technique. So if you look over here, this is what we have as the object, which is in 3D shape. It is exactly the same example that we were working over here. Now when I project the top surface, I get this surface and I get this surface, which is drawn right here on the top surface of your glass box. So now the surface that is highlighted in gray color is an inclined surface. Rest all the surfaces, you will see they are at perpendicular to each other. So this surface is perpendicular to this surface. But when you look from here, this surface and this surface is not perpendicular to any surface, so it's not at normals. So it has an angle, and that's where we need to find the size of that surface. So when I project this onto the side view, which you see over here, you can clearly see that the surface is foreshortened. In real life, the surface should be this big. But now in the front view, I see the surface is foreshortened, and the same thing I see in the top view is foreshortened as well. So the only way to get the correct size of this surface is to change our line of sight in this direction, which is going to be perpendicular to the surface of the object. So when you look, the projections are done. This is the top view. This is the side view. This is the front view. And this will be called as what? The auxiliary view. So that's what we are going to learn in this chapter, is to how to draw different types of auxiliary views using the folding line technique. Now in the folding line method, the object is suspended in a glass box like you see over here to show the 6 principal views created by projecting the object onto the planes of the box. So this is called as the frontal plane. This is called as the side plane or the profile plane. And this is called as the top plane or the horizontal plane. Now we are going to see how we could draw this auxiliary plane using our tools for drawing. So this is going to be a 6-step process. I'm going to call it step 1. In step 1, what I am mainly doing is making my folding lines that is parallel to my inclined surface. So if you look over here, this is my inclined surface, and I have my folding line drawn parallel to this inclined surface. In step 2, all I am doing is completing my folding lines by drawing a line for the top and the side view. Now one thing I have to remember is this distance has to be same as this distance. Now why is that? Is because we are going to transfer this depth onto right here so we can find the depth of the object. Okay? Same thing we are going to do is find where our auxiliary view starts, which is the same depth as this from the folding line to the object, and where our auxiliary view ends, which is going to be from the folding line till the end of the object, which is going to be from here till here. So that way we will be able to find the depth of our auxiliary view. So in the first step, we found and drew the folding line. We have our line of sight for our auxiliary view. Now in step 2, we are going to get our distances and measure it. So the distance from the folding line till the back of the object is going to be measured as x, and then we are going to draw the back of the object from the folding line till there, till the back. Again, this measurement is going to be same as x. Correct? We have to project our lines, guidelines, at an angle of 90 degrees to the inclined surface. That is extremely important. And once we do that, we project our lines in step 3. Now all this could be done in a couple steps, but we're just trying to learn how to go about doing our auxiliary views. Now in step 3, all we are doing is projecting our guidelines at an angle of 90 degrees. In step 4, what we do is we take our protractor and measure the distances from the folding line, so we are able to complete our auxiliary view. So from the folding line, I put my protractor and measure this distance. Okay, and this is going to be my protractor with the pointed edge. Then I'm going to use my protractor, move it to here, the same exact thing with the same distance we just got, and transfer that dimension to our auxiliary view. So I take this distance, which was x, remember we measured that before. Now that is the same distance that we transfer over here. So what we get is the back side of our object. So all I have to do is draw a line going from there till there. So we've already found this one. Now we need to find the front one. So that's what we are going to do in our next step. Now we are going to move the protractor and measure the distance from the folding line to the front of the object. We measure this distance and we are going to call it y. Now we already have the distance x. Now we are going to take this measurement from the folding to the front and transfer it up here. So this you would be doing it while you were drafting, but after you learn how to draw the auxiliary views, you really don't have to worry much about doing that, because it's just going to come in automatically, and you just measure that distance with your scale and then transfer it right here. But for beginners, it's important to understand how we transfer the dimension. Okay, so this was y, sorry, that was x. Now this is y, and I'm transferring the y dimension there, and this is where my front of the object, which is this surface, is going to come in. So you see over here, we are transferring the depth of the object onto our auxiliary view. Now the next thing we have to do is step 6. This was step 5. Now in step 6, we just have to finish completing our auxiliary view. So we have this distance and this distance from the folding line, this and this. This was y and this was x. And we just transfer it right there. So when I'm looking at the object with this line of sight, this is what I see. So now if you look, I see two surfaces, there and there, which is that and this. So I have to darken this edge. So now in here, which is the true surface and what happened to this surface right here? So if you see, the true size is going to be just this surface. Why? Because it's first of all perpendicular to it, and this is our auxiliary view. This is what we really wanted. But when I'm looking in that direction right there, I'm even seeing part of the top surface. So that has to be drawn over here as well, and this is a complete auxiliary view. But all we're worried about is this one right here, because the top part has now foreshortened. So if I want to get the measurement for the top part, I have to get it from here. Okay, I cannot get it from here. Why? Because when I'm looking at the top part at an angle, I'm going to see that surface as foreshortened. So I hope you understood these 6 steps, but we are going to do a lot more exercises. So we are using the folding line technique, where we draw the folding line parallel to the surface which is inclined. Now the incline could be 30 degrees, it could be 60 degrees, whatever angle, it doesn't matter. Then we have to make sure our folding lines are at an equal distance from the object in the top view and the side view, as well as my auxiliary view. Okay, so and then we go about measuring the distances from the folding line to the front of the object, from the folding line to the back of the object, and then transfer it on our auxiliary view till we get our desired auxiliary view. Now this is a simple example. You will be working with a lot more complicated example. This example that we just did is similar to the next one that we are going to do here. Now one thing you have to understand and know is there are 3 different types of auxiliary views. One being the depth auxiliary view, one being the height auxiliary view, and the third one being the width auxiliary auxiliary view. Now, the difference between these three is the depth auxiliary view is projected from the front view. So you look over here, this is the front view, and this is where it is projected from. And what we get is the depth dimension is shown in true length. Now in the height auxiliary view, you see the difference between this one and this one. In the height auxiliary view, the auxiliary view is projected from the top view rather than the front view. So that's the main difference between these two. And when I get to the third one, the width auxiliary view is the one where it is projected from the side view or the profile view. Everything else still remains the same, but it depends on what principal view you have an inclined surface, and that's what you are going to be using to draw the auxiliary view, either the front or the width or the height. Okay, so let's look into this one, which is similar to what we did over here. We have the isometric view of the object, so you can visualize how it's going to look like. So my front view is this one. This is the top view, and this is the side view. Now if you look over here, this is the front, this is the side, and looking down like that is the top view. Okay, so first it's important to understand how our view is placed and which type of an auxiliary view we are going to use to draw this. So I'm using a depth auxiliary view in this case. First step I will have to do is draw my folding line starting over here, which is parallel to my inclined surface. Second thing is I have to continue my folding line and draw my object at an equal distance. From my folding line, so that, why? So that I can transfer my dimension over here to my auxiliary view. So I'm going to measure X, I'm going to measure Y, then again from the folding line I'm going to get, this is X, from my folding line I'm going to get Y, and the same thing out here is Y. Okay, now to get this surface where we start with, I'm going to project my distance from folding line for X, which is going to be from here till here for X, and this is where I draw my line going from here till here. Now I'll have to measure my distance for Y from the folding line, which is going to be from here till here, which is where my object ends, and I'm going to make that line. Okay, then I see this surface right here, so I'm going to make that line go like that. This is the surface, so I'm going to finish that surface, which is foreshortened surface. Then my object ends right here. So I will draw that line. And the only part that is left for me to draw right now is the inside of this surface, where I have this whole curve along with a hole in the center. Now again, I need to measure these distances from the folding line. So what I'm going to do, I'm going to measure distance from here till the front. I'm going to call it A, which is going to be the distance from here till the front, which is A. I'm going to do another measurement from there till there. I'm going to call it B, which is going to be from the folding line till there, which is going to be called C. Okay, all I have to do is make my guidelines going that way and going this way from A till C, and I will have to complete my object by drawing right there. Let me zoom in a little bit. So this is the distances which I found, which is A and C. And my top part is going to be nice and round. Okay. Only thing that's left is in the center. I do have another hole. So for doing that, I could again measure another distance from my folding line till the center, transfer it right here, and make sure I put my circle with the right size or right diameter. Now it has to be a perfect round circle. So this is called as my auxiliary view. And the only true size over here is this. And that's the reason why we were drawing our auxiliary view in the first place. Now what about this one? This is foreshortened. So next one, we are going to see the height auxiliary view, in which the auxiliary view is projected from the top and the height dimensions is shown in true length. So the first thing we'll have to do is draw our folding lines starting over here. Now our line of sight is going to be from here, looking in this direction. That is what is going to give our correct auxiliary view. We have to make sure that we project our lines from the auxiliary view. We are at an angle of 90 degrees. So we get the true size and the true dimension. Once we are done with that, we are going to be measuring the distances from our folding line. So if we look over here, we are going to be measuring from the folding line till this distance right here, which we are going to call as x. Then we will transfer the same thing onto this side, x. We are going to get from the folding line, we are going to get the other dimension, the distance for y, and we will transfer that same dimension till here, which is y. Now we have to make our lines. So for this surface, I start from here going all the way up till there. The second one, going to start from here, go all the way till there. Okay? Then we have this edge, we project it up here. Then I'll need to transfer the distance from here till here, which we can call as A, just from here till here, and another distance from here till there, we can call it as B. Same thing, we transfer from the folding line, transfer one, which is A, and we transfer another one, which is B. Okay, so A comes up till here, B is up till here, so I'm going to make another two lines. From there till there, and from here till here. Now we have to finish this view. This is the edge that we are projecting, which is the same as this that you see here. So I'll have a solid line going like this. The object ends over here and here, so that's what we have to put right there and right here. Now we just have a couple more lines left, is from this edge, because our object that we are trying to get the auxiliary view is from here till here mainly. So I'm going to draw that line, and I'm going to draw another line over here. So that finishes my height auxiliary view. So our auxiliary part is going to be from here going all the way till here. And this is the true size. Now which one is the foreshortened size over here? Is that one and that one. So even if we don't draw this and our object was just drawn just that much, we were good enough. Just like that. Okay, so I hope you're following this. Now the next one that's left is the width auxiliary view is projected from my profile view or the side view. Now what we are using over here is a little different. Instead of doing the folding lines, I am doing a reference line. So it's pretty much still similar, but instead of going through all those lines, all I draw is a reference line that's touching the object over here, and then I am going to transfer my dimensions going this way, going that way, and going this way. So first I get a distance from here till here, which is what we have. So that's going from, so I'm going to draw this line going up here. Then I'm going to go back this distance, which is going from here till here. Then I'm going to go up this distance, that's from here till here. I'm going to find this distance from here till here. That's where my object ends, from here maybe all the way up to here. Okay, again go up, go inside, go up till here. Then I'll join this line. I'll have to join this line as well. Once we are done with this, now we have to see how far does this base go. Now if I look at in my isometric view, so this base is going all the way till the end of the object. Now if I were to project it, I would project it from here, and that would come somewhere on this side up till this distance. So I'm going to draw this line. Now this is for the base, approximately maybe up till here. Okay, then put that line, make sure I complete my base. I will be doing the same thing on this side because it's going up till this point. Do that. Make sure this thing joins. Now what we are left is with this top surface, which is the same as this, because when we are looking at this angle, we'll be seeing the top part as well. So I will draw that going from here till there, from there till here. I have this one edge and two edge, which is one edge and the second edge. That's one, and that is the second. Okay, so now we're pretty much done with the object. Now the only thing we need to do is put the circle or the hole right in the middle. And this is where it's projected from. It will be somewhere in here in the center. Now one thing about auxiliary views, you have to understand that now this surface is inclined, so none of the views we can see the whole as a complete circle. I cannot see it in the top view, front view, side view. Only way I'll be able to see it as a perfect circle if I were to look in that direction, which is again perpendicular. That's how we have this line. So auxiliary view will be the only view where we'll be able to see this as a perfect circle. So I'm going to draw my circle there. Right from the center. Okay, So that's our auxiliary view. So if I were to shade my auxiliary view, that would be the surface that I just drew. Okay? So that's drawing an auxiliary view, or drawing a width auxiliary view, where we projected the profile, which is the profile view, and the width dimension was shown, like if you look over here. Okay, so this is the auxiliary view that we got, which is the true surface of this angle, and that's what we are really worried about.